Hello there. My name is Matias Concha, and this is our presentation for bad forecast prediction models to Unilever case. This is our index for today, our team. And first one, we have the introduction. So, Unilever wants to know about some possible prediction models that can forecast some bad predictions which could complement their previous bad forecast models. And we choose three algorithms: logical trees, whose dependence variables are categorical, so binary, then decision trees, which are like branches that break down, and finally, we choose neural networks, which process data like a human brain once are trained. Our development, we use some simple package to Python, just like NumPy, Pandas, and then we use scikit-learn to these models, and TensorFlow for the instances, settings, and processing of the models using in the project. Re, that is regular expressions, and TimeDelt for the manipulation of strings and representations of time duration, respectively. And this is our base that we use. The first step of preprocessing was preparing of the main base for the task. So we select some feeders. Um, some of the most important are the variables semana and año that were made with the fecha feature, gramos, marca, and segmento, that are in grams, brands, and the segment, respectively, of the products sold in each observation. And then we wrote the target binary variable, yes, which the value is 1 when venta de unidades is less than forecast venta clientes and 0 in otherwise. However, we dropped three of them. That was fecha because it doesn't provide relevant information, venta unidades, and forecast venta clientes features because to avoid collinearity that can distort in the true performance of the algorithms. And the fourth processing task was standardization and train test splitting. We first one used the standard scalar, importing this tool to standardize the features into the three models. Then we train the test split, implementing the train test split function, dividing the whole main dataset in 60% for the training process, and the remaining 30% was used in accessing the model with unseen data. And finally, we use the target variable for the train and all the other data sets into binary integers to the model, to the predictions.
Okay, so for logistic regression, we use the train variables with a maximum of 50 iterations, and we obtain the following results. Final accuracy was 78%. So in first place, we have precision, which is the proportion of true positives among the total positive predictions, like both true and false. And we have recall, which is the ability of the model to identify all true positive cases. And we have the last metric called F1 scores. This metric indicates the combination of precision and recall in a single measure. So these metrics was the following for the logistic regression: 80% for for good predictions and 61% for bad predictions imprecisions. And talking about recall, we have 93 for good predictions, 30 for bad predictions, and for F1 scores we have 86% for good predictions and 40% for bad predictions. For decision trees, we created and configured the sorter with an 8 max depth to avoid the overfitting. Final accuracy was 80%. So, like I said before, um, precision 83% for good predictions, 63 for bad predictions. Recall, 92 for good predictions and 44 for bad predictions, and the F1 scores 87 percentage for good predictions and 52 for bad predictions. And finally, for neural network, we use an input equal to 80 features, and we have the hidden layer made with 18 neurons. For the output, we have a singular neuron, which is going to classify whether the forecast is bad, like the number one, or if is it not not bad, or in other words, good, with the number zero. We select a number of 25 epochs or iteration for our models. The final accuracy of this model was 82%. So the precision in this model was 86 for good predictions, 65 for bad predictions. The recall was 90 for good predictions and 55 for bad predictions. And the F1 scores, I'm sorry, 80, 88 for good predictions and 59 for bad predictions.
Comparison of models. Well, as you can see, we made four simple comparison tables of the main predictive performance radius of the model. In all of them, the neural network presents the best prediction. However, in terms of interpretability, it falls behind. The logistic regression models is ahead, and the easiest to interpret corresponds to the decision tree model. In In the results, we obtained some weeks of the year where the greatest number of bad predictions were obtained. In the same way, it was done with the months and some of the stores that present the greatest annual predictions problems. Conclusions. The recommended model to implement is the neural network. In spite of their complexity of interpretation, after the data preprocessing, it is easy to implement. Also, it is the best predicted based on the established metrics of F1 score, precision, recall, and accuracy score. If you want to understand the classifications process, it is recommended to implement an adjusted logistic regression model to improve the metrics. In this way, interpreting the classification process is easier given that the model is linear and does not present greatest complexity. The company must constantly monitor the number of bad predictions to be able to make inventory purchase decisions in time in case it has exists. Unilever must establish a maximum number of bad predictions based on your records. That is, at what point the number of bad predictions will affect the business with extra cost due to inventory overestimation and expiration of this inventory. Also, you must pay attention to the critic months mentioned in the results, in which the bad predictions are more than 5,000. To be more specific, the mentioned months can be intersected with the weeks with the greatest number of bad predictions, over 1,000. These are the last week of January, the second half of August, and the first of September, and the last 2 months of the year. Finally, to avoid wasting resource, prediction improvement efforts should focus on the sources that are mentioned in the results parts of the report.